Yeah, so we're going to tag team this. My name is Michael Dielman. I handle the business pieces of Twistlock, but I also come from a technical background, electrical engineering, hardware, Docker, and then abstracted up the stack to here. And then Andreas?
Yeah, so I'm Andreas. I'm also technical background. I work for several companies, most of them startups, and a lot of time with Mike today.
Unfortunately.
Yes.
So, I think the thing that's important about this, and when we looked at the keynote as things opened up, is this is about ideas and concepts and themes. A lot of the times, the details of how you code something out one way or another, unless you're taking detailed notes, you're going to have to look up later. So we're going to talk about some themes and hopefully engage in some conversation. We're going to introduce this idea of shifting the whole security model left. And we're also going to have a little bit of fun with that, because it's getting later in the afternoon. You guys have seen a ton of presentations already. So we are going to move through that. For those of you that don't know or haven't heard about Twistlock yet, we are a cloud-native cybersecurity company focusing on, obviously, security and also compliance of not only containers, but the whole cloud-native stack, and that encompasses things like serverless. We saw that today. A lot of the abstractions that we're talking about in terms of orchestration, and also things like Istio. Right? We believe that containers can improve security. They don't necessarily, by default, improve your security. But we think that there's some major themes in terms of switching the model towards a more proactive, going towards a whitelist approach. We were the ones that introduced that whole new model into the security realm and kind of turned things on its head. So now, let's dive into it. Okay. So one more thing to keep you guys on your toes. You need to pick out which slides Andreas and I built, and then which slides our marketing team built. All right. So we're all talking about the concepts of DevOps. We know software is moving quickly. New tools are needed as we move into new paradigms. We also know that because you have the democratization of software, you have open source software, you also have the open sourcing of things like cybersecurity attacks, right? So it's always a double-edged sword. There's always trade-offs between the benefits of a technology and the drawbacks, and we know that complexity is never really created or destroyed. It's kind of shifted around in the stack. So just some stats to put some framing around this. We see DevOps being adopted across the industry. With that, organizations, I think there's only a small subset of those organizations that are actually thinking about security proactively as they set up those pipelines, as they set up best practices. Right? Thankfully, R&D is one of those. But there's a lot of organizations that get down to the end, they're going to production, maybe an app's already in production, and they say, oh, what about security? What about compliance? Right? We think that the other way makes a little bit more sense to go proactively design that, but there's also elements that you can do iteratively around the process. The other element is, as we have code moving quicker, those organizations that actually do have some element of security built in, they're actually receiving so many incidents, they don't know it's actually relevant information. Right? If I'm receiving so many different things, I have a noise level, and I don't know what I actually need to take human action on. So there's a huge gap between those that actually have some element of security, but then actually know what to do with that security information when they have it. So this is the part where we're supposed to do the typical security presentation and scare you into giving us money. But we like to think of it in terms of more practical sense. There's obviously a human process element to that. Right, I should insert doom and gloom here. This is where we talk about Tesla. This is where we talk about British Airways getting hacked, how unpopular it is, how expensive it is to the brand, yada, yada, yada. But I think really the element that most of us in the room care about as either developers or operations guys is, right, there's actually a human element to that, right? If an application that you're responsible for either running the infrastructure for or developing, and there's a vulnerability that causes a loss either of customer information or not, it's embarrassing to you as a coder, right? The regulations that exist on top of that, we could throw out terms like compliance and GDPR, but the idea is that's really insult to injury at that stage. It's too late, right? Your brand has already been kind of dragged through the mud, and then on top of that, the government's going to go tack you with a fine. We think that there's another mathematical way to look at it. And we think that risk can be also thought of as an integral, right? So we have an exposure, an event happens. The amount of time that that exposure is actually exposed to the internet is, the longer it's exposed, the higher the risk of attack. And then there's also severity factor, right? And this goes with relevance. And the other element of the relevance is how much that vulnerability actually exists in the context of your environment, right? If I have a vulnerability, it's sitting upstream in the context of one of my packages, it's actually not running on a server anywhere, it's probably a lower priority than something that exists on more instances across my infrastructure. So containers can improve security, we all know this. It's all magic and unicorns. Oh, too far, you can't see my beautiful clip art. Or I mean our marketing department's beautiful clip art. We know containers are declarative, immutable, consistent, automatable. We have the reduced attack service capabilities, and we're also using things like microsegmentation in the context of Kubernetes to help us reduce the blast radius if an attack should occur. But we know there's also trade-offs, right? We have these great benefits of containers, but as we handle some of the complexities around those containers, such as moving from an entity where I was going with 100 VMs and moving to a world where I have potentially thousands of containers or microservices, I'm adding complexity to the equation. And so how do we solve complexity? We solve complexity with abstraction. But what happens when we abstract? We lose visibility, right? So these things are all related. So we think that this kind of promotes, or I guess presents us with two problems. One of them is we have our code that's changing rapidly, and as a result we have a moving target, and our security models are lagging behind that. And then the other thing is our code is being deployed faster. And this is where we see things like runbook models, et cetera, begin to break down. Static firewall settings that are manually ticketed tend to break down, and you see drift from your application to your security model lagging that severely. So we think containers can improve security, but we all know that DevOps means that devs are God, and they can do whatever they want. And we see a lot of organizations that are actually running containerized applications in production already. Why? Because these are serving real applications to clients that they need, right? There's business reasons, right? Those get accepted. The question is that as we move into a world where developers have increasing power, how do we add the right degree of control over them, right? How do we reel in the wild, wild west? And this really is something that we think at Twistlock should be a team effort. And we'll go into that in a little bit. So we do have new attack vectors. There's hackers out there, and what are they doing? They are doing, basically, as you have a DevOps process, there's more opportunities to drop packages into applications. Binaries can be injected, etc. Anywhere along the line, dev, test, staging, prod. And then there's also a new set of attacks that are being exposed because of abstractions, right? Whether it's Kubernetes or a new type of orchestrator or the interface between those orchestrators and the underlying infrastructure in the context of hybrid, right? So lateral attacks, cross-site scripting, malformed syscalls, etc., right? Privileged escalations. The other element is that just like we're automating our infrastructure, hackers are automating their attacks, right? And the chain of these attacks is becoming increasingly more complex and not visible to traditional security systems that are having a difficult time correlating the result between something that happens in my runtime and an element of my code that sits in a registry or is working its way through a pipeline. So we like to think about things positively because this is a marketing slide, clearly. And so it's not a problem, it's an opportunity. So we already introduced the concept that, right, the static model is kind of breaking down. Moving from the reactive model doesn't really work anymore. And the runbooks are really, that's kind of the traditional model that a lot of organizations do have. That's the legacy, right? Someone that may or may not develop the code is setting a set of standards, putting a set of capabilities that this application can have, but the problem is as soon as that application deploys to production or iterates the next day, if I'm doing daily or weekly deploys, that runbook's generally not valid. And that applies not only to security, in terms of an application level, but it also applies in terms of your runtime environment, right? And this is where we have a traditional model where we have things like pen tests, and pen tests are like Christmas. They come up once a year, and then you never have to think about them again until next Christmas, right? You kind of covered your ass for lack of a better term, and then you don't have to think about it. The other thing we see is there's also same thing happens with firewalls. It's a long, drawn-out process to go get ports exposed. As a result, there's a lot of privilege escalation that happens in the process of a dev process or an ops deployment process to go get that application into running. So there's an incongruency between the security model. It's not portable, but we have these portable entities that are containers. So how do we make a model where our security model iterates at the same rate that our code development is? And this is the whole concept of shared left. It's a shared responsibility model. One of the things I like to do, because you always need to poll the audience before you do one of these talks, is say, how many people are devs? All right, how many people are ops? How many people are security? All right, and then everyone should raise their hand for security because we think it should be a shared model. And part of the beginning point for a shared model means that people need to be working off the same sheet. The problem is developers have always had a set of tools, operations has always had a set of tools, but devs don't know the ops tools, ops doesn't know the dev tools. So there's a breakdown in visibility, they're speaking different languages, they have different capabilities, they have different insights, whether it's application layer or infrastructure layer. The other thing is as you move into more complex attacks, you have more complex infrastructure, you need to be able to automate things. If you don't automate, then you come up with a whole bunch of security tools that really aren't usable, right? We have to filter out the things manually or cross-correlate a tool that sits in the context of a dev stack and a dev environment and a dev flow versus an operations piece. So a couple more opportunities. For this slide to life. There's also a human element of this. I know this is kind of conceptual. We'll get into the demo in just a second. But I think most developers that we come across, or ops folks, would prefer to know about the things that exist in their code before they go into a design review and get the shit kicked out of them, right? Being able to automate this and enable the right people with the right information is another thing, right? We talked about relevance in the beginning. Being able to get that information back to the appropriate development teams is incredibly important. It's a big piece of what Twistlock does. So we talked about traditional manual processes. If they're manual and time-consuming, generally they don't get done, right? So the good news is that there's something that can automate all this, and this is where Twistlock comes in to save the day, kind of like Chuck Norris. Twistlock comes in, we provide vulnerability management, that's the upstream piece. We do compliance, it's another big thing, especially in the context of insurance, I'd imagine. PCI DSS may come in. There's also different standards as it relates to ISO that may affect your business. And then there's threat protection, both in the context of static elements of your infrastructure, but also running containers as well in your runtime environment. So the challenge with most models today is, as mentioned, there's a lot of things that do scanning, right? Scanning has been around, it's not a new idea, right? There's a whole bunch of legacy vendors that do scanning, right? It's great, right? It should be a part of every kind of your defense in depth concept, right? And then there's a lot of things that do firewalling capability, right? There's a long laundry list of vendors. The challenge is these two models have never talked together, and that's really what Twistlock came in to do and change. Is say, rather than having my dev and operations team spend cycles trying to correlate the data between 5 different tools, doesn't it make sense for these models to be friends? They should definitely be friends. That was well worth it, right? It was the dramatic pause. And so that's really the magic of what Twistlock does is, what we take is this idea of our static model that we're building, on the next slide, our static analysis that we're building as a part of your CI/CD process, machine learning, which is a capability that allows us to simulate the runtime behavior of an application in terms of file system capabilities, exposed ports, etc. But we make these two models interlace. And with that, we can use the concept of declarative programming right? Containers should be these immutable objects, and we can actually use that to say, well, now we know exactly how an application should behave. Anything outside of that model, we can block against or alert, right? And that's really the power. We go from saying, I need to block an infinite number of things, right? And the blacklist is always getting longer, to saying, why don't we just know the desired behavior and enforce that? That makes sense. So we take that, we build a predictive model. We also take that intelligence feed and take over 30 feeds, and Andreas will show you this. But, and then we have a security research team that's making sure that you're actually spending your time on the relevant things, right? And that really ties back to how we understand not only your application flow, but we also understand your runtime environment. And so we know if there's an application that's sitting in your registry, but it's not actually instantiated as a container, then it's not really a risk, right? It's the images that are actually running and exposed to the internet that do pose that risk. So that's a little bit about the concept and the design philosophy behind what Twistlock is trying to do. And Andreas will now do the architecture and demo.
Yeah, and feel free to ask questions at any time. I think we have enough time to go through them. Yeah, before I dive into the demo itself, I would like to show you the architecture of the product itself. So first of all, we think that containers are more secure than if you install the application on a native operating system. So we decided to package ourselves into containers. We only have two components. First one is the console. It's basically a graphical user interface. It really depends on if you like graphical user interface or you hate them. You can also use a binary tool to work against the Twistlock console, or using a REST API to trigger any kind of configuration, any kind of automation that we do inside Twistlock itself. We easily integrate into any kind of environment that exists. Our most important thing is the intelligence stream. Why is that so important? Because we have more than 30 different feeds collected together and put this information into one single channel. Those feeds have information about what are known vulnerabilities, so what are known attack points against these vulnerabilities. So we have an active researching team inside of Twistlock that is actively analyzing any kind of vulnerability that is on the market and how hackers are typically using them, right? As Mike said, most of the attacks are automated, so we try to find out, okay, do they try to conquer your services, how do they try to conquer also additional services. We put this information also in the intelligence stream and try to find out if one of your systems has been actively hacked. It's really important when we talk about containers to start with container security at the moment when you're building them, right? You should also even start it earlier when the developer is writing still the code and is trying to build the container. But latest at the moment when you're doing your CI/CD test, then you should be able to do security scanning and start to analyze your containers if they are affected by known vulnerabilities, if they're affected by malware, or someone is trying to do some weak configurations inside the containers that could be potentially used. And the other components that we have is basically the defenders. So you use the graphical user interface to define the policy set that you would like to apply in all of your systems. Then we have defenders running 95% of the time as a container. So we only install a side container. What is he trying to do?
Siri is listening.
Okay, Siri.
She's very interested in cybersecurity.
Yeah, cybersecurity. Wrong words. Okay, yeah, so the Defender itself, it can run as a side container. We have some special privileges in the underlying engine, so we're able to analyze all containers running on this whole system, and we're also able to protect them, right? So don't allow to call specific malware things, or don't allow to change file system, whatever you would like to stop doing inside of the container. Then we have more and more customers coming to us and say, hey, this cloud native tool thing is cool, but we're still in the old world, and as you said, Kelsey Heisentower said that databases shouldn't be run inside containers, even on Kubernetes. So we have also the old world, the traditional world, where you can also install the Defender as a service in Windows or as a daemon in a Linux environment. And then all this fancy stuff, you might not see it here, but it's on the right side, like OpenFast. Unfortunately, we don't have an integration to OpenFast right now. We will have in the future. But all the major vendors in the market, the cloud vendors, we are also able to protect the function as a service there as well. Are there any questions to the architecture? I hope that's refreshing fast enough. So the challenge that you have typically in a cloud native environment is exactly this, right? So I'm using a stupid demo environment here with some applications that are deployed. That's quite easy. But when I take a look at some reference customers that we have that are building out one application out of hundreds of different microservices, then it could get really complicated. And as you can see, this is the high-level overview. This will be the default view also in the next release. So you start with a visualization of what is the security health of my whole environment here. And let's wait a second. You can see I can zoom in, zoom out into my environment. And as you can see, this here, for example, is a special or a default that you can use as a sock chop from Weaveworks. And as you can see, all the communication that is done only inside the application itself, it will be a nightmare if you're still doing this manually, right? So if I take a look at how did the configuration of all the communication that has been done here on layer 3 between only the containers, I didn't do that much, right? So when I take a look at my firewall configuration, I only enabled it to alert mode, but I didn't specify any rules, nothing manually. So those times are gone where basically trying to get ports open by requesting it into a ticket and changing one of your 400 million, let's say, firewall rules with the security team, that will no longer work if you have microservices that are under heavily development, right? And if you're adding more and more services, more and more functions to that, then this will be a nightmare to manage that with the traditional tools. So the way how we do this is we're putting all the containers that have been started inside the environment into this learning mode. So we try to analyze what are these containers are doing, right? What are the containers they are communicating with? And then you will see easily, okay, for example, this front-end microservice is talking to this ordered microservices. And that's what we learned. Now when we make this rule active, so after the learning phase, then we are able to basically block. So if someone is trying to access from the front-end server to the MongoDB, as an example, directly, then this should be blocked, because it's not of the learning that you use for your microservices here. And we can drill down into that, right? So we can take a look at, okay, what are the ports that are being used here? We can look, okay, this one is allowed to talk directly to that specific microservices. I can take a look at each single microservice. You can see they have different colors that are being used in the radar. And for example, when I highlight this one, I get all the information I need about this specific microservices. So what is the image that is coming from, and which namespace is it running? What are the labels that are being used? What is the operating system? So Alpine Linux, by the way, is a great idea if you would like to run containers, because the footprint is much, much smaller compared to the traditional operating systems that are on the market. But I also see the information about, okay, what are the vulnerabilities that we have for this specific microservices? What are the compliance risks that I see? So those are the typical two things customers start using our products. So they scan the images about known vulnerabilities, and they also scan the images about any configuration issues they might have with their compliance requirements. And then you see a third thing here. So we're also analyzing these containers when they're actively running. It's not only that we're learning about the communication between these containers, we also learn, okay, what are the default processes running inside a container? Is someone trying to spin up new processes? Someone's trying to run any kind of command inside a container? Then we can actively drop that and make you aware. We can alert you and make it visible to you that someone tried to do something inside the container. Is someone trying to change a file configuration? Someone trying to touch files? Someone trying to add new files? Someone trying to change processes, binaries, and start them as a replacement? All of this will be automatically checked from our side, even syscalls, right? So in the underlying Linux kernel to find out if someone is trying a syscall that wasn't being part of what we learned so far. And I can drill down into this. I can pick this specific one and get the whole list of vulnerabilities. So be careful if you start using your products, you will be highlighted with all the vulnerabilities, right? I've seen customers losing, let's say, control about, okay, where should I start to focus on? I mean, having a list of vulnerabilities is a nice start, but the second most important thing is, okay, where the hell should I start to focus on all of these vulnerabilities I have in my applications, right? First of all, good recommendation is always to ask yourself, the binary that has been affected, the port, the library binary, whatever is inside, is this really necessary for the service that I'm running inside my production system? So the first thing you have to ask yourself, do I really need it? And if I need it, is there a patch available? If not, if there's a workaround available. We take this information, for example, we also have the risk factors, the CVSS information about every single vulnerability that is here. So we want also to know, okay, how can this vulnerability be potentially used, right? Is there a network attack that is possible? Is there an exploit existing? So exploits, that's really bad because then we know that active hackers are using this. And I can take it from here and go into my vulnerability management and also see additional information about, let's say, all the images here, go into one of the images. And I can also take a look at the layer level, right? So when you're using Docker, you might add more and more layers into the Docker file itself. But the thing is, in enterprise companies, that means that you have different responsibilities for different teams, right? So you might have a team that is responsible for this layer on top here. So here you'll see that they did add this number of vulnerabilities into this specific layers. Or if you go down within your Docker file, then you can see that there's a package manager being used, and this is also adding additional vulnerabilities into this level. So you can start this finger pointing and say, okay, you're responsible for the base layer. There are this number of vulnerabilities. Please start to patch that. What else we do? So as said, having a list of vulnerabilities is nice, but having something like a vulnerability explorer is even better, because then I can start to drill down and say, okay, let's start to focus only on the top 10 of the most critical vulnerabilities. So now you could ask, why is Twistlock able to say what are the top 10 of the vulnerabilities for my specific environment? The reason is because we also know all the information, not only about the CVSS information for the specific CVE, but we also know exactly how this is being used in your environment. So we see if there is a container actively listening on that specific port that has been affected by the vulnerability. And even worse, so developers make their life easy, right? They create a Docker file, they use root, they have full root privileges. That's good for them because the application works. That's bad for security, because if I'm conquering the service and in the underlying container I have root privileges, then I might be able to also escape from the container in the underlying engine, which is worse. Especially if you also have no security profile attached. No SE Linux, no AppArmor, so I'm not even limited inside the container from starting other things. And as you can see here on the risk tree, we are able to show you, okay, those are the images that are basically affected by this, and we can start to search, okay, which one is the most critical. And as you can see, this red container is highlighted because it fulfills all the threats that we marked for this specific container. So this container should be one of your first containers where you're starting to patch, implementing a workaround, and make yourself ready against this vulnerability. So we make you actively aware about what's going on inside your environment. We do this for the registry. We do it also for serverless, as said, right? So serverless, by the way, it's a much better idea, because most of the serverless functions you see today on the market, they have no vulnerabilities. But that doesn't mean that there are none, right? So as you can see, those are Lambda functions in AWS. I also have this for Azure, but there are still some with some vulnerabilities. And if you're using them, then even your functions could be affected. As said, the earlier you start using the tool, so we have a Twist CLI scan that you can use. You can trigger this also from a Jenkins plugin, whatever kind of CI tool you would like to do. Immediately start to do security scan. The second topic is compliance. So compliance, everyone hates compliance, as it's typically not easy to do. We try to make it as easy as possible for you. So first of all, we are not reinventing the wheel. So we're using what's on the market. So there are benchmarks from the Center of Internet Security, how to best configure my containers, my images, my host, my daemon, all the things I have running below my containers, or even if you have a Kubernetes environment, right? So there are specific requirements for managers, workers, or if you have multiple clusters in federation mode, then it's also a special configuration. We have our own compliance rule set requested from customers that we can use also everywhere. And you can even completely customize that or use the CIS benchmark for Linux operating systems if you like. And typical systems, things we see here, for example, as I mentioned it some minutes ago, is that containers are running with root privileges. So the first thing you can do is here, sure, it's now configured into alert mode. So if anyone is starting a container with root privileges, I'm getting an alert in my system, in my CM system, my logging system, wherever you would like to have this alert. But I can also start to block this container and say, okay, here in my production environment, no one is able to start a container with root privileges, right? Privileges is another keyword. As if it's not even running with root privileges, what are the developers doing? They're using full privilege. And what does it mean? I have full access to the underlying engine itself. How can you stop developers doing this? Do not use privileged containers, block. The good news is, if one of your developers is starting to run a container with Docker run, or if it's a kubectl command create, then they immediately see that it's not possible to start this specific pod or container because it's been blocked by this policy. It's specified that in a production environment, no one should use root privileges containers. Or other scenarios like sensitive information. Developers make their life always easy, right? So they put the password of the database inside environment variables of the container that will be started. That's a security nightmare, because then I'm total out of control. Who can read that specific information, right? If I'm not controlling who is running docker inspect, docker ps, or kubectl commands, describing pods, then everyone can see the password in clear text for the specific container. Right, and a much better approach, the guys in the back will do the talk after that, is the Vault key integration, right? So we have an integration with Vault, so you can attach this encrypted value information into the container and make it visible for them. That's what we do from a compliance perspective, right? As you can see, there are many settings that you can do. Compliance could be a lot of work. We make it easy for customers to start doing compliance, let's say for GDPR, for PCI, for NIST. Our CTO is the lead author for the NIST compliance. If I'm selecting that, it will basically select me the right configurations that I have to fulfill to be GDPR compliant, PCI, or whatever you would like to fulfill. And then you're using it and make sure you're compliant and you do no longer have any vulnerabilities in your environment. But are you then fine with security? What do you think? So I have no vulnerabilities in my container. I have the best hardening guide in the world. No one can hack me. Is it true? Maybe there are vulnerabilities that you have no idea that they exist, right? Things like zero-day vulnerabilities. And our research team is also putting this information inside the intelligence stream to make you aware that you are being maybe actively hacked, right? And before you ask, okay, how is Twistlock protecting themselves? Let me do this here in the other environment. So we have this container model that we're creating, which is the whitelist of allowed things inside my container. And as you can see, we are using ourselves to protect the console, for example, right? So we're using ourselves to learn, okay, what is the normal behavior of our own console, right? What are the binaries that are normally started from an entry point perspective? What are the ones that are being started right after that? And I can see that this entry point is starting other processes. And those are the ones that are okay for me, because that are the ones that I learned doing the machine learning, right? And everything that is not part of this list is an audit, isn't it? Everything that is being triggered from externally will be highlighted. Or the networking perspective, right? I want to know which specific binary is listening on which specific ports. I want to know what DNS resolution has been done. Is the hacker trying to connect to a crypto network and is so stupid in doing a DNS resolution, right? Then we will immediately highlight that. We will see if he is actively connecting to outbound ports in that case. Or we can identify him doing bad stuff in the file system, right? So normally, only the processes that are running should be able to change something in the underlying file system. If it's the container file system, if it's external storage, we should know that, right? And we can also see the sysballs that are being used in the underlying kernel. So how is this being configured? It's quite easy in the runtime policy. So first of all, we're protecting you against known malware and communication to external IP addresses that are outbound IP addresses not allowed, let's say to crypto miners, to Tor network or whatever. And we are also able to protect you against the Kubernetes attack, right? That's what happened at Tesla, right? So they had the default admin password configured, and everyone was able to log in and publishing new pods on the system. So if someone is trying to publish a new pod, and what did happen at Tesla? Someone started a wonderful programmed crypto miner, the one that was only using as much CPU as the normal services were using. So no one didn't find out, okay, there's some 100% usage of my CPU. No, it was so intelligent written that it was only using 10% of the CPU. So no one did find out that the crypto miner was right. If you're not earning your money with crypto miners, we have customers doing that. So we make it optional, right, to also allow using crypto miners. Lateral movement, that's a typical thing. There is no single reason, I've never seen any reason why an administrator should be able to access a container that is running via SSH, via Netcat, whatever kind of admin tools you're using. I've never seen any, right? If you want to change something to the container, you do this in the image. You do the redeployment, and then you have to change, implement it. So if someone's trying to do that, we can also monitor that. And as said, if someone is trying to start my MongoDB from a command line, then we also can highlight that, because we know the child relationship between the processes, right? So what is my endpoint doing, or is this done by an active hack? And as said, we're also doing DNS monitoring and port scanning. There are some reasons why you could use a port scanner, but in general, that's what hackers are doing, right? So they try to conquer your container, then they try immediately to do a port scan around the same cluster to find out what are the ports that are open, what services are running on top, and where can I attack now, right? So these are the typical behaviors of attackers, or they also try to change the certificates, right? They replace the certificates so they can, they know exactly how to break the tunnel to your system, for an example, or being part of a middle attack. Whatever attack things they're trying to do, we're able to analyze this or find out if someone is trying to hacking your SSH configuration in the underlying host. So that's what we do. We're not doing this only for containers, we also do this for hosts, so we can also analyze services that have been actively hacked. And if something is really strange going on, we immediately highlight this as an incident, right? Because I want to know if, for example, someone is starting a crypto miner, right? So I can see that there was a crypto miner being started. It did happen on this specific container, in this image, at this time. And I can see what kind of crypto miner that was. I didn't block that, so you can see the response is alert. But if you want to know, okay, what exactly this happened on the system, I can drill down into the forensic data and see exactly what someone was trying to do on the command line on this specific container to analyze if you are hacked or not. Funny thing is, especially I had one customer where we did put a system with a known CVE in the internet, and he was immediately able to see how this system was being hacked, right? Yeah, we also do this for serverless, right? So serverless, there's a specific function, a specific process, something is called. Everything that is outside of that should be blocked, right? Why should someone starting other functions or other processes in the background? That doesn't make any sense. We also do this for Fargate. So if you have Fargate, we're also able to install a Defender in that environment. Yeah, and as I said, we have this firewall capability, and as you can see from this view, I'm also able to immediately drill down into all the incidents I have for specific services. And we also can do some web application firewalling. So we have also layer 7 firewall that is able to analyze the whole HTTP traffic that is going into a container. The beauty of that solution is, if you have already web application firewall in place, we're not bounded to anything, right? So we can attach this web application firewall simply to a Docker image, independent of where it is when we were started, in any of your hundreds of Kubernetes clusters, independent of what networking tools are being used. You can use this to actively protect your HTTP traffic and also HTTPS. Yeah, that's basically it, I think. We're fine from the time, right?